Hello guys, on this video I want to explain the equation of equilibrium. First of all, I want to introduce myself. My name is Usman Abdullah. I'm a structural engineer. Okay, to make it simple, generally the equilibrium of body require for both balance of force and balance of moment. Okay, for balance of force is to prevent the body from moving or translating or having accelerated motion. Okay, for straight or curve path, but for balance of moment it's to prevent the body from rotating. This equation we can conclude it as two equations: summation of moment equals 0, summation of force equal 0. Okay, here we have small example signpost as we see here in the pic. The height of signpost is 13 meter. The signpost length is 5 meter by, for width is 3 meter. As we see, it's subjected to pressure 500 Newton per meter square. Here they ask for internal loading a cross section through point P, and also it's given the signpost is fixed to the ground. Okay, let's solve it. It's very simple. Okay, at point P, as we see here, we have X direction, Y direction, and Z direction. At point P, we need the force, internal force. Here we have force on the X direction and on the Y direction, and also we have the resistance moment and torsion if we have. Okay, as we see here, we need force at point P on the X direction and on the Y direction, and the moment also moment at point P and the torsion. To solve it, first of all we can convert the pressure to concentrated load. As we see here, we have a pressure of 500 Newton per meter square. We can convert it to concentrated load by multiply by the area of the signpost. We can go here. As we see, the length is 3 plus 2 is 5, and the width or height is 3 meter. That means 5 times 3 equal 15. We can multiply by the concentrated load by the pressure. We get the concentrated load. As we see, 7,500 Newton. This is the concentrated load for the signpost. We can convert it to kilonewton. It's equal 7.5 kilonewton. Okay, to solve it, to get the force on the X direction, as we know the summation of force at the X direction, we can see here. If you see at the pic, this is the X direction. Now we want to get the force at the X direction. We can assume the force at this direction and the concentrated load, as we see, it will be at this direction. Okay, we assume Fx direction as the negative side, at the opposite, and the concentrated load as the opposite side. Now we get Fx minus, because the direction is different or opposite to the concentrated load, plus 7.5 kilonewton equal to 0. We get the Fx equal 7.5 kilonewton. Okay, this is the force on the x direction. Let's go for y direction. For y direction, here we don't have any load except the on weight. Now here we do not have the on weight of the signpost. Okay, that means the force at the y direction equal to 0. Okay, let's go for moment at point P. The summation of moment at point P equal to 0. Here we will get the resistance moment at this direction, at the opposite direction. Now we have concentrated load at this point here. Moment P minus 7.5, this is the concentrated load, multiplied by the lever arm or the length from here to point P. That means from the center of signpost to point P. That means 3 over 2. We will get the center of the signpost plus 6. That means 1.5 plus 6 equals 7.5. 7.5 times 7.5 equal 56.25 kilonewton meter. This is a moment of resistance at point P. Okay, let's go for the last torsion at point B. Okay, as we see here, the signpost, it's fixed not at the center here. As we see here, 3 meter, and here is 2 meter. This different distance, it will generate torsion at this point. Okay, we can calculate the torsion. As we know, the concentrated load will be at the center of the signpost. That means it will be at distance from here, because this is 5 meter, over 2 will be 2.5. The concentrated load will be at 2.5 from here. Okay, 2.5. And here we have 2. Now we can calculate it. The 3 plus 2, this total distance, over 2, to get the concentrated load at the center, it will be 2.5 minus 2, this distance. This is a eccentricity. Eccentricity is 0.5. 7.5 times 0.5, summation of this, equal 3.75 kilonewton meter. This is a torsion at point P. Very simple. Thank you for listening. Wish you all the best.